turned off, so let's get started here. Well, thank you all for joining me for the first of many presentations. This is the 2019 Monthly Basic Training Program. You may have seen the schedule. Obviously, you have if you're joining us now. So let's get to it. To start with, this month we're going to be talking about tank heating basics. And as you can see by this, gaudy cover page, there's all kinds of good stuff to do with tank heating. And it's a most common application here at Chromalox, and you can use pretty much all of our products to service this market or to service these applications. And I'm going to discuss strategies, designs. We're going to go over competition and how to design against them, to price budgeting. We're going to go through that in the second presentation. Also going to have an update on the pick and ship, and also provide all the resources you have available for calculations, for design criteria. I'm going to show you a little bit of the configurator in the second presentation. But all of these monthly basics, any of the presentations we're doing, however, are designed around increasing your knowledge, your credibility, and the value and support that you can provide your customer. The idea is that if the customer sees you as an asset in the, electric heating, that's your value. That's what you're selling to your customer. Your value to them in knowing the options, knowing how to implement them, and also knowing your resources. Pulling in an RTSM or maybe some colleagues that have experience in these applications. And I'm going to illustrate some of those along the way as we build our library of applications and references for you to give to your customers. To start with, to this day, I still say the tank heating brochure is one of the better brochures that we've produced. I take this with me everywhere. I keep it in my backpack or your briefcase, depending on what you use, I guess, the market you're serving. And I leave it everywhere because it really does illustrate the breadth of product and options we have available for any heating application, which makes it a lot of fun. That's why we work here. We enjoy our jobs, and let's go through and break a lot of those down as we go. That brochure, if you don't have it, is the PX131. Order it. Get the download will come with the summary at the end of the presentation as well to everyone's email. But you should have these on hand. You should really carry these with you. So let's walk through it. So your heating options. So we're going to go with basic tank heating and expand on that. But to start with, immersion heaters. Okay, we got your screw plugs, you got your flange heaters, very mechanical in nature on how they affix to the tank. And then we have specialty tank heaters, the pipe insert, the thermal well, replaceable elements designs. We're going to talk about dry and wet wells and how competitors do it to what we offer and how it can be misconstrued. I have one specific slide that I put in all my presentations when talking about tank heating that kind of illustrates the relative to what, as I say a lot of times when somebody describes an application or a product or anything, relative to what a pipe insert or removable element design, everything's removable, so you have to kind of illustrate what we mean by that and how that is applied. I've got some details, some detailed slides and discussions on over-the-side heaters, which I, to this day, still find one of our most versatile, useful, and profitable options to customers with existing tanks or even in designing, unique, we'll say, heating applications for tank heating. We'll go through the circulation heaters, give you the options for exterior heating of the tank using these models. Heat transfer systems, which personally I think we don't sell enough of. The new designs, the MWSs, the MOSs, our product line is getting really to the point where this becomes a viable option. We're very competitive price delivery on these. Steam generators. Been selling them for years. Okay, these are your boilers, right? Steam heating. You got jacketed vessels, tanks. I got lots of examples of those. Talk about strip heating, tank heating for hoppers and surfaces. Heat trace, always an option. And comfort heaters, yes. Comfort heaters for tank heating applications. I've got a few examples of that to just prove my point and show you how to do that. So let's start with the first. Somebody's banging around out there. Let me go ahead and mute you. Okay, make it a little easier for everyone. Immersion heaters. So this basic slide, you've seen it before. You know, direct immersion, I mentioned before, very mechanical in nature. You either, you know, threaded MPT. We do have British thread available if you're overseas or you need another option for a threaded connection. However, the flanged heaters. ANSI flanges are standard. We can do, you know, square flanges and modified flange connections, but the most common one is your ANSI flanges, your standard 150, 300 pound. I'll go through the designs of those later. But, you know, the most bang for your buck, you're putting the heat in the product. They're very efficient. Now, we say virtually 100% because, yes, there's losses, the voltage, power, connections, all that. We can go through that argument. But I will say we're in the high 90s of efficiency of what you generate goes into the tank, goes into the product, goes into what you're heating. So they're very efficient. Probably, I mean, virtually the most efficient thing you can put in a tank. Easy install. We have some removable designs, which we'll discuss in a minute, which leads us to the cons, right? So if you're putting it in the side of the tank, if you're, you know, flanging it up, using a gasket, if something goes wrong, and I'm not saying the heater went wrong, it can happen. Maybe it's, you know, corrosion, maybe it's failure, maybe it ran dry, maybe it's the electrical wiring, maybe the power flux. Anything that goes wrong, you have to drain the tank now to replace or service the element. So we've got some design considerations to look at for that. And also we'll talk later about the design of watt density and element selection to go with that. So enough about that. I thought I would throw in a few examples to give everyone on the call, because we have people with various experience levels, just the pure volume of design, and maybe point out some of the things that you'll see along the way. Now, this is just a simple walkthrough of our factory in Utah, and you can see this is basically the kitted up packages. So these are the elements already produced and ready to go into a flange. Here's one being worked on currently. You can obviously see the number of elements that go in there. That would be our rod baffle design on the spacer plates there. It just gives you a real idea of the variety, the pure breadth that goes through the Utah. So maybe when you're talking lead time and delivery, you can understand that just the variety that goes through there. I can tell you that unit there specifically, you maybe saw the little note on the side of the flange, that was for lifting. Each heater has a little nuance of design specific to either the application or the customer, and we have to be very conscious of that. This is a good end shot of, this would be our hydro test station. These big vessels here in the middle, this is everything, after everything goes through manufacturing and then assembly, after the elements are welded to the flange, they have to be pressure tested. We have to make sure the welds are going to hold so the tank doesn't leak. Those are basically holes in the floor where they do the hydro testing for all of our flange heaters. They can go up to you know, thousands of PSI to meet any ASME design required. Quite capable facility. Been around for a while. I showed this one more of a walkthrough of the terminal assembly area. You can see where they space the elements out for good heat transfer. There's those rod baffles again. Threaded terminal housings for fire protection. There's little screw plugs. There's somebody working on the terminal end seals. And you can, again, just get an appreciation of the variety of and the nuances of all the little designs that we're about to discuss. Painted terminal housings, E2. There's some of our One World design terminals. We have that big threaded box there with all the terminal connections. And here's the point. Any point along the manufacturing of these units, any little variance or something that's out of spec, they can't check the resistance at the end. So if you weld the elements and you do all the production, quality still has to do a check at the end. And just so everyone's conscious on the call, and something we run into a lot of times where people are, you know, deliveries and manufacturing issues, if something's out of spec at the end, they have to go back and rework it a little. That takes time, so that can impact things. So just to maybe have a better perspective and understanding of how these go together. And the variety. I mean, in that picture alone, I can see steel elements, alloy elements, and copper elements. Pretty much the standard. Stainless is not illustrated there, but, you know, there's a variety of everything that goes into all of our products, and we're going to talk about those expertise to help with your credibility and design in the second presentation. Going through the products some more, the other option beyond your standard immersion heaters, I like to call them the traditional design, right, with the sheathed elements. are the insert heaters or the removable heaters or the pocket insert heaters or however you want to reference them, the replaceable element heaters. We call them our LTFX or STFX, so large tank flange heater. S is for the small tank flange heater. The X was for extreme duty, as I know we've copyrighted that in a few different places in our literature. The FXTH is still very much out there. It was actually the predecessor to the LTFX and the STFX. The FXTH would be the square flange design for, say, the horizontal tanks. And it's also used to this day in specialty connections, not an ANSI flange, is basically the way of looking at that. Now, we do consider this a premium product. You're going to pay a little bit more. Also, remember, because it's in a well, the heat transfer is not as good. So the element watt density comes down a little bit. So it's physically larger a lot of times. So that impacts the cost. So it's something to be conscious of. Delivery is generally about the same as our traditional heating elements, but something to remember. Now, we do have third party on our hazardous terminal housings. There's a special seal for the LTFXs that we have our own design for. And these are really good, again, premium product to offer for tank heating for extended installations. The tank's going to be there for a while. This is definitely something to push and look for your customers. And it also gives you the variety of options to offer in tank heating so you can compete with a wide variety of competitors and also offer your customer the most options available. One of the biggest design factors for the LTFX that I think no one pushes enough of is right here in the bottom left, and it's illustrated just with the drawing. And you get in these larger tanks, they're going to put up a containment wall, or there's going to be other tanks in a tank field that go up next to it. It allows for the removal of elements. It's, a really nice feature. So, some things to consider. Give you a kind of an idea how they run through. Here's that ceramic core, the open coil running down through the middle that slides in. These can be extremely long, but I wanted to show you that photo, or at least a little bit of that video, to give you the other illustration of these elements are assembled. That's not a manufactured product. It's the ceramics and the coil winding that go in there. So you can get replacement elements really quick with this if it's a problem with the customer. So something to consider, something to remember as a value to that. Now, the slide that I mentioned earlier that I put pretty much in any of my applications or any of my tank heating presentations was a slide I created a few years ago. Pipe insert. When we first started pushing this premium product, we focused on the pipe insert aspect, the removable elements, which is very much a selling feature. But then you have to consider your audience, and that's something that I think we've evolved to realize at this point. Pipe insert can mean a lot of things to a lot of people, and if it's not the mechanical or even the electrical, maybe it's just the purchasing agent, it's still a quote heater. Oftentimes, even though we feel that we've had it designed, spec'd, and exactly what maybe the end user or maybe the engineer had in mind, we'll miss out a lot of times on the order because they will go and source a less premium product like the traditional immersion heaters, which we certainly make, but we've specified and designed for the STFX and the LTFX, not realizing that they're considering a removable element, even the traditional design. And you have to be really cautious, and you have to, that goes through the whole communication of talking to the engineers, talking to the end users, but also talking to the purchasing agent. Knowing where the project is and who's looking at it, and to make sure they understand the difference. Because quite frankly, I can cite many examples where that's tripped us up, and ultimately you lose out on a sale, and you have to be really cautious. So I would encourage you to take this slide, expand on the slide, and explain to customers, what it is we're offering and what it is we're providing when you go with a more premium product, because there's a higher price, there's a larger design. And you want to be careful because somebody else can walk in and pitch a bayonet design or a replacement heater that very much, depending on how you define that, meets that specification, but then again is not yours, where we can very much provide that option had we know they were going to go that way. So just be careful when you're using terms like pipe insert, bayonet, well heater. So, I just want to point that out. Then system mounted, I noted at the bottom, which is a very nice thing to have, is here on the right of this next slide. You know, we say it all the time, and I push it more and more, and I just want to reiterate to everyone on the call, you know, obviously we're doing the heater and controls. And we very much want to provide the controls part of that heater. The heater is the needed reason why they've contacted us. We've got to heat a tank or a process. We got to control it. So we're providing a control panel. But I think it's one of the best bargains we have to offer is the system mounted, the pre-wiring. I explain to a customer a lot of times, look, we package the panel with the heater and the interconnecting wiring all for this, you know, for the price that's in the catalog or you can get it quoted. And therefore, you're saving money not only on doing that in the field, you're saving money on the electrician to come out and do that wiring, to do the separate circuits, to do the signal wiring. And more importantly, it gets tested at the factory. So if you do have a problem with that, anything between our panel and our heater, if we do it in our factory, that's our responsibility. And that's a value to the customer. Now, if we sell them the panel and the heater and they wire it up themselves, then that kind of opens up the door for, did the contractor or the electrician understand what was going on here? Did they understand our product and how to match it up together? And it really is a kind of a safety catch for the customer. So in my opinion, it's an easy sell with a customer when you explain it out to them and show them the value and examples of that, and I'm happy to provide that. Another thing, and not to skip back just a little bit on the pipe insert design, I probably should transfer these around. You know, we sell the replaceable element design, the LTFX, the SCFX. There are a lot of designs out there and a lot of installations that still use traditional heating elements in a removable design, in a well heater, or in the case illustrated here, the tank heat transfer system, I like to call it. And I see these everywhere. I see them commonly in oil and gas. I see them in railroad, municipalities sometimes. Remember, EPI has a regulation where the element has to be removable without draining the tank, right? The petroleum product, that's part of the specification. However, the way around that is to put a heater inside a well and then fill the well with heat transfer fluid. And they do that a lot of different ways, and I really love this example. Thank Brad Rayson for sending it to me. You know, essentially they've created a well in the tank. They put heater, straight catalog heater, right, TCN, and then they fill it with a mineral oil or some kind of glycol, and you can even see the drain on the bottom of it. And this just acts as an expansion tank. And there's various examples on how this is done. There's the standpipe and the condensate tank heaters everyone's heard me talk about, so many. And it's more common than you'd know out there. Now, this is an easy replacement for an LTFX. Maybe if we'd talked to them earlier, we could have done that. But what's really wrong with this picture, and that I can tell, does it heat? Yes. There's a tremendous amount of heat right here in the nozzle. You can clearly, I mean, it's cooked off the paint and it's burned it up. So that goes into the design considerations that you want to discuss with the customer. You're helping your credibility. You're showing them, look, yeah, heat, but let's talk about how you're applying it. Let's talk about the design that you've implemented and how better options that you have available, which we do. Any questions there? Okay, well, we'll move forward to one of my favorites, the over-the-side heaters. I'm having a tab issue here. Okay.
Hey, D.Eric.
So over-the-side heaters. Yeah.
Couldn't we say, too, the efficiency drops with that style? You know, it's burning the paint off and all that, but it's out of the tank?
Absolutely. That is a huge impact. You may find that they need less heat because that's all waste.
Right.
You're heating the environment at that point. None of that heat's going into the tank. And I have that discussion a lot, and I have some examples there in a minute. This is a design consideration we can't focus enough on, from the tank manufacturer to the engineers responsible. What is your nozzle size, length? What is the distance from the tank? Because ultimately we want the heat in the product, not heating the heat sink outside the tank. And this happens all the time. Does it work? I mean, sure, but like you pointed out, that would be wasteful. But more and more, and I have a tremendous amount of examples of this, polymer and FRP tanks, fiberglass reinforced tanks, are becoming more prevalent, and they still need heat. And we need to be conscious of that and make sure that we design the heat off into the process and not in the nozzle, where clearly you can see, you know, this is a steel tank. Is that a big problem? No, not so much. It's a loss, but it's going to run fine if it doesn't burn out first. But if that's a polymer tank or an FRP tank, this would be a tremendous problem. It would start leaking. It would start, it would start to move a little, and then they look and see our red box, and they're like, oh, Chromalox did this. And that's where your credibility and your discussions with your customer need to involve those questions, those design criteria. And I want to provide you as many examples, as many photos to illustrate that as well to them. And again, you'll have all these at the end. A great point. So over the side heaters, again, I get really creative with these. I know a lot of folks out in the call do too. You know, these are great for existing tanks, tanks that didn't consider heating before and don't have a connection on the side, maybe didn't, have an exchanger or a jacket. You know, you can still use the traditional heating elements. You're still submersing them in the product. But now you can get really creative with it. You can do a lot of different things. Maybe it's an open tank where they're doing some kind of dipping process or coating, and you need to get the heat down below. You know, they're replaceable, they're serviceable. So a lot of thoughts, a lot of abilities with these things, and I really want to kind of get into some of the modifications, we'll say, and the customization that you can do with these, because they are quite handy, and quite frankly, there's a lot of money to be made with these. This is a great example, and we don't, and to explain how this works, this is an EP over-the-side heater. This is for a tank where they didn't realize they needed heat. They had to supply heat later. They still need it. They still need it sealed, and they still need to meet the area classification. But how do we do that with an over-the-side heater? Well, in our catalog, if you look at the BLCK, it has this illustrated, and this is one using the TRI or TLIs. What we do is on the riser, right? They'll actually thread the riser, and from there you can now apply it through the tank through the manway or other connections at the top of the tank, maybe a vent, and you can literally put pipe fittings on it and clamp it down. And then from there, you add your EYS seal and your terminal housing. How those install in the field, they simply thread together. You pop your Chico in there. Bingo, you've met the area classification, and you've provided heat into a tank that otherwise wasn't designed to accommodate a heater. This is a $15,000, $20,000 over-the-side heater that they had no other option but to go this direction. I mean, this is some of the design abilities of these over-the-side heaters. Maybe you're just going down into a port and you want to just bend the elements to the side. Easy enough. Right through the top, bent over, all done. So lots of great design considerations and options available for over-the-side heaters. And, call me if you, want to go through or you have an application that requires something that unique. Another option or product that we provide for for tank heating specifically is not actually heaters for the tank. You've got to pump product into the tank. You got to pump product out of the tank. Why not put a heater in line there? You can have them simply install a three-way valve or a bypass and have the product heating constantly. It provides agitation to the tank, one, good heat transfer, and you can service the heaters quite easily. So circulation heaters are very much an option for tank heating, and really great to use. Some examples you can do with heat transfer systems. So if you're not heating the product, you can heat them with coils. You can heat them with jacketed vessels. We do that all the time. Water HTS systems basically, and we got a whole month on them next month to really get into the details of those. But this is just a really great indirect option to offer your customer. Some examples of that, and I've talked about them for years, are in the oil and gas world. You saw the ports here for the heat exchanger, this large tank. Well, this was a heat transfer system that they were upgrading and we swapped out and used used our heat transfer system for heat transfer fluid to go into the tank. It's you know, obviously you're trading efficiencies from a gas-fired system to an electric. That's fine. Maybe even a good option for some of our new direct connect for these larger tanks. You got to put the input into there. So, you know, everyone's seen my oil and gas presentation, so you've seen my various examples of that. However, even on installations where they already have gas-fired systems for tanks, there's also still the loading and unloading areas for these tanks. In the case of this asphalt tank, we used CMXs just to heat the area to and from the tank instead of where traditionally maybe heat trace would be an option, but they needed higher temperatures. So this was an easy install to slide into place. And to my point of jacketed systems and vessels, I wanted to show this just because it illustrates for maybe some of you on the call who don't see or know what I'm talking about specific to jacketed vessels. A lot of times you'll see the perforated looking jackets like this, and this is one connecting to another one. Now this is an auger. This isn't exactly a tank. Same principle goes along that way, and this was a project I worked on a while ago. But this was as simple as replacing the heat transfer system with an MOS, a straight catalog item to do the process. Some of you might wonder why there's donuts in the picture. That's precisely what they were processing through there to make cow feed. It's probably a longer story than we need for this discussion, but I thought it was a good illustration of what a jacket looks like. You know, it could be in vessel, could be in an auger, could be in a process, but it's an indirect way of heating a product using our heat transfer systems, which is great. And to take it a step further, steam heating. I know that we've got our new direct connect boilers coming online, which is fantastic because it creates a whole world of steam heat that we previously merely touched upon. But even your smaller applications, we're talking, you know, manufacturing processes. There's a good example of that's an asphalt facility there in the bottom. You know, again, indirect heating of a tank or a system. Boilers are a great option. Maybe, you know, you can use an inline heater to boost up steam, but let's generate the steam in some cases. There's a lot of ancillary products we can provide with these. And I'm going to show you a few examples of how that gets applied and how valuable that is to the marketplace. This application specifically, some of you might get a kick out of this just because I'm in Colorado, go figure. Cannabis, you know, CBD oil as it's the popular concept. So here's a case where they're extracting oil out of most, you know, marijuana plant, right? But this is really true in even pharmaceuticals. I wanted to show you a real-life application. I didn't have pharmaceuticals in front of me. This is a jacketed vessel. And what they do is they pull a vacuum on it, and they heat it with the steam. That little boiler heats that unit under pressure. I'm sorry, not under pressure. And they pull a vacuum in the thing, and once they release the vacuum, that steam dissipates in the vessel uniformly because there's no airspace. Once you add airspace, all the steam takes up that area. And they're pulling the oil off of there. And that's a simple application of oil extraction, which there's a lot of that in other various applications. But that's at the simplest basis. That's all a steam heating jacket vessel looks like, heating a tank. I wanted to point that one out specifically because guess what else we can offer them? Sarco would be excited to know that we can provide their stuff, right? Steam traps. At the time, I had to help source some of this stuff. Not even thinking they could have called our folks, you know, at Spirex and got the extra ancillary products to go with that. So I just thought that was a good illustration of that. And then, you know, you've got food. In this case, this is an example which, you know, Nate Hill did a fantastic job with, where we're doing, you know, this is cheese. Well, there's dairy and cheese and food prep everywhere, and they use steam quite commonly because it's, first of all, it's a secondary heating source, jacketed vessels, all that, but then it meets all the sanitary restrictions. The inside of the tank can still be sanitary and meet your FDA requirements. So in this case, you know, that whole industry is serviced by gas-fired boilers. Now, their boiler had reached the end of its life, so you can see the big one there on the left that we just swapped out for our nice little catalog item again. Wires up, takes up much less space. Heck, they had to build a little stand for it to get it off the ground just because it was so much smaller, right? And that whole system is feeding, heating the tank, heating the troughs to, again, make cheese. That was an easy transfer of design, and again, tank heating, but done with steam. It's a great option for tank heating when traditional immersion heaters are not a viable option, and you should explain that to customers. And even markets that don't, have traditionally gone with indirect heating, we have options available to provide them. It's great. So speaking of indirect heating, I'm going to skip over to pad heating, surface heating. We got silicon laminate heaters, we got strip heaters. You can use heat trays. Hopefully you all saw where, our traditional panel heaters are now considered tank and tank heating bolt-ons. They're in the catalog. You can pick multiple hopper heaters, for one hopper and make an indirect, easy, redundant system to help out your customer and give them the criteria. Look, there is no leaking involved because we're not making any connections to the tank. We're heating externally. Now, is it as efficient as an immersion heater? No. But depending on the application and what you're trying to do, it might be the right option for your customer, and you need to explain that to them of your different choices out there. And a good example of this we had come up, this would be a dipping tank through the top, right? And you really don't want any interference inside the tank. So simple strip heaters strapped to the bottom, right out of the catalog, selected, wired together. And in case you do or you don't know, but I want to point out, the connecting method to your tank is already provided. There's a part number for it in our catalog. That's as basic and simple as it gets. And we do it all the time. So now you've gone from, I just need a heater to, well, what kind of heater would you like? What are you trying to do? Let's design around this. What's easier for you? More importantly, do you need this tomorrow or do you have time to wait and design? In the case, of a strip heater, we stock so many different design strip heaters, we can get you out of trouble quickly and give you that option. And then there's, along the lines of surface heating, there's also the heat trace, right? There's self-regulating, there's MI cable, high temperature. Again, not as efficient, because we're heating through the wall, but to and from the tank, piping, this is the ideal application for this product. And we're going to spend a lot of time on heat trace this year, and I won't stick on that too much, but the purpose of tank heating, I do want to point out, so a lot of the replaceable element slide that I provided, this is another one that I keep a lot in my slide deck, we'll say, when I'm doing tank heating, and I like to illustrate this to customers because depending on the customer, depending on their experience and relative to what their experience has been thus far, they may not even be considering immersion heaters. I've throughout my career, I constantly run across people who only talk heat trace, who only talk pad heaters, who only, a specific technology of heating, where we have such a variety to offer them. It takes a little bit to get them out of their comfort zone, right? And then when you have the discussion of efficiency, much like Tim pointed out earlier, that's wasted heat on that nozzle. Let's talk about, a little bit of different design to get more out of it, for your heater to cycle less, for it to last longer, for you to be able to service it. In the case of this specific example, and I like to show people, is, initially you're going to heat trace a tank. And you have to install the heat trace on the tank, so that happens. You have to test it out. It goes all over the tank. Then you insulate it. And then, assuming there's no connection issues, you didn't nick the insulation, there's no problems, then you can proceed to wiring it up and move on. There is a lot of money in just the installation alone and time it takes to put the heat trace under the insulation of doing that. And the example of this, I was actually talking to Floor, and I don't even want to tell you the cost savings it would have been had they bought the $10,000 immersion heater and just slid the immersion heater in there. They could have bought 15 immersion heaters for the price they would have saved. And you need to make sure that brochure that we had illustrate the different options that are available. Again, heat's heat. It's all on how we apply it and how it's dissipated into the product. So that's something that you want to illustrate to your customer. You know, help them understand their options available, and especially working with Chromalock. Now this one's kind of neat. You'll see it in the brochure, and I want to talk about it a little bit more in detail. You know, air heating for tank heating. Now that seems kind of counterintuitive, but there's two sides of it. Now one, you've got the ancillary buildings and all the personal areas effects that would require air heating. But some cases, like in the case of this polymer tank here, this was in a facility and there was 15 of these tanks. They actually just heated the facility. They just needed to maintain freeze protection here. It wasn't a big deal. So they just maintained the building at that temperature, and there was no heat required in the tanks. Well, that's nice. And that's understanding the application, and that's walking them through it. Other situations, like I illustrate here, this is one of my favorite places, Arapahoe Basin ski area. This is their water treatment facility, and they have a buried tank down below there. Now, the tank's below grade, doesn't necessarily need heat, but there's access. This is the auger that goes down in there. There's access ports in the tank that require not obviously to maintain the temperature, right, to avoid icing and freezing and problems. So they use comfort heaters inside the building, and to maintain, basically, in this case, this is a tank heating application without a heater in the tank. I show you the one on the right. So you've seen the traditional water towers. They don't do that everywhere anymore. They bury the water tanks. And when they bury the water tanks, there's a pump house built beside it. That pump house, where it comes in and out of that tank, that's a huge thermal mass. That's never going to freeze. There's no issue there. But where they're pulling it in and out, that part of the tank has to be heated. That room gets heated. And that gets heated, in the case of Denver Water, they use LUHs. There's no reason why it can't be an HVH or an HD3D. But again, that's where you're using comfort heaters for a tank heating application, something I wanted to point out to everyone and kind of illustrate some thoughts there. So that's, a little bit of a breakdown of everything illustrated here, and you should be able to talk to that and give a customer their options based on their application. Say, look, I've seen, it done this way, I've seen it done that way, and here's your savings, here's your considerations, and here's how I would design it. And this all is along the lines of helping your credibility, walking through the value you're providing to your customer, and then ultimately, obviously, getting their confidence and getting the sale, right? So from there, we'll move a little further to, some of my previous trainings where we talk about the actual design, the considerations, and these are the things you're going to be able to provide. And I'm providing you with the tools and the programs at the end of this to go through that. And in the case of this one, we're obviously talking tanks, so that's great. We all know the heat calculation, right? Thermal calculation, which is essentially your specific heat, your delta T, your input in BTUs, which is going to ultimately apply to your, KW or what the heat we're providing. Simple thermodynamics at that point. There's, obviously the laws of thermodynamics. We're most interested in the first law of dynamics, which is the conservation of energy. You think of stuff as heat always goes to cold. That's why we want to know what the environment is like there. We want to know what the worst case scenario is so we can calculate the worst case heat loss. But then there's also the thing to consider too. How often is it the worst case? There's a certain design consideration in larger tanks where how long does it take to freeze? Based on the thermal mass, it might take a week to freeze. Is that going to happen? Probably not. So then now we can start to use that into our considerations, and maybe it's not the 20% safety factor anymore as much as it's, we probably need about half that, because there's also thermal gains during the day. There's also considerations of running it, when it's not necessary and bump up the heat a little bit. There's a lot of little things you can play with just knowing the math that you can help your customer understand and provide the right KW and the right design consideration, which I'm going to kind of go into detail here in a little bit. So where do you start, right? So there's a list of questions. I'm going to provide that to you on a spreadsheet, which is nice and easy. So if you don't already know them or inherently know to ask, you'll have them right in front of you until repetition gets you there, kind of thing. So, what are you heating and why? What are we trying to do? I mentioned the size of the tank matters, the thermal mass. Maybe there's fill rates. I point that one out specifically because a lot of times especially a tank application, especially at a loading area, so you got storage, you've got loading and unloading, and you may be doing a calculation for the full size of the tank, but in reality, let's say it's a 5,000-gallon tank, but you're only putting 1,000 gallons in at a time. That's a different calculation altogether. You're not trying to heat the 5,000, you're trying to maintain that, but you're only heating the 1,000. And that's just one of many examples, but that's where you have to know the applications, the fill rates, how often this is turning over. Maybe it's a process where it's circulating off to somewhere else, and they're using the tank as the storage portion. That's important to remember because maybe you may have a flow rate that's really high, but a total volume that's even less than that. So you're not even heating the volume because it's important to remember KW is rated in kilowatt hours, or at least our heaters in our catalog, that's the output rated over an hour. So that becomes an important part of the calculation. Then the tank type. What are we heating? What is the shapes? What's exposed to the environment? The material itself, if it's a fiberglass tank, that's actually kind of an insulator. Actually, not kind, it is an insulator, which is so you have to calculate for that. It's not losing heat like a metal tank. And they may still insulate, they may not, but like I tell customers a lot of times, we don't make insulation. We don't even sell insulation, but I encourage you to insulate your tank. So that's a big side of it. Heat sinks. Shockingly, you'd be amazed at the trouble they cause and how much heat can be lost from one manway cover that's not insulated, or a couple connections, or even the flanges themselves to the heater become a big heat sink. Agitators, maybe there's something in the tank. I mentioned before with like the dip tanks, we couldn't put a heater physically in the tank, but we still needed to heat it. So we got to think of other options, which is why we walked through the PX131. Then insulation. Again, we don't make it, but we strongly recommend it. And we can calculate it based on the R factors, and I'll show you how, and you can add it to the spreadsheet that we provide for you at the end of this. And then wind is a consideration. So the questions are there, the data sheets are available. What are we heating? What are the volumes? The application specific is very important to know what we need to input into the process, what we need to input in for the customer. So therefore, it's all the makeup of how the heating requirements come into play. What temperatures are we trying to achieve? What are we trying to do? And most importantly, what is the timing for this? So don't fall into the trap of you've got a volume, a tank, you do the calculation, like, look, I need 100 kW. Yeah, but we've got 6 days to heat it. Oh, well, that's completely different. You need 100 divided by 6 minus your losses per hour. That's completely different. So it's important to remember the ratings are per hour. When you do your calculation for thermal input, it takes that much input, and then you're applying it per hour. So heat up times are very important in that calculation. So, geometry, that's easy. We calculate surface area. That's your losses to your environment. That's the exposure temperature to the air, the sea, the water, the ground, wherever the tank is at. We can calculate it based on the tank shape. The supports and stands become a heat sink, so you have to calculate for that, much like with your heat trace calculator. They ask you how many support stands or how many connections are there. Because those are heat sinks, you add more heat trace there. Material of construction. This one's a lot of fun. Metal tanks, great. Bolted tanks, we misconstrue this all the time. They'll use steel bolted tanks all the time for the support and structure of steel, right? That's easy, it's strong, it holds up. But then they come in and they line the tank with something. And you have to be very cautious of that because, one, if the heater's there, they're going to line our heater. Or if they're lining the tank, what is in the tank? The tank may be steel, and we may match up the steel with our heater, but there's something corrosive in the tank, and we need to make sure our elements last. Then, the polymer and FRP tanks that I've been mentioning a lot, there are a lot of design considerations to be careful for with these. One, all their flanges are going to be rated based on the physical size. So if they have a 150-pound polymer tank or FRP tank, nozzle connection, that means it meets the bolt pattern. It doesn't mean that it's rated up to the strength and stability of 150-pound flange. A little bit different. And then you have to be careful because I'd say 9 times out of 10 or even more than that, it's flat-faced, where our standard on our flange cheaters is raised-faced. That doesn't seem like a big deal, but when they go and torque that down, they've now cracked the flange to the tank, or they've caused problems with the gasket. Either way, it starts to leak, and they look at us like it's a problem. So just be conscious of those when you're designing those. Another thing with the nozzles of FRP tanks is they're not always the pipe diameter, like schedule-wise. They get out of tolerance really easy, and the problem with that is they'll get our heater out there and they can't fit it into the nozzle. And so you want to be really conscious of connections with polymer tanks. And you just ask. You get that's one common dimension that gets missed on a lot of heaters. We worry about immersion length and cold-in length and those type of dimensions, but also consider the bundle diameter. And make sure the customer acknowledges the bundle diameter and it's going to fit in their tank. So nozzles become a very important part of that, as much as the flange face itself. So have that discussion with your customer, walk them through it. Again, you're just building your credibility with them. Hey, have you considered this? Well, let's talk about it a little bit because we've got all the options available. We just want to make sure we're matching up to your tank properly because no one may have brought it up to you prior. Again, helping with the credibility, helping with the value. Heat sinks in the tank. This one's always a lot of fun. A ladder, a support, any of those things are giant heat sinks to a tank. They're pulling heat away, just like they do, with the fins on the outside of our panel. That is a loss to the tank, and that needs to be considered. In the case of this one where I have the manway actually shown, this one was a lot of fun, is environment too. Environment can play a big key because, when are you filling the tank? Where is the tank stored? Because if they fill the tank cold, there might be a huge thermal, impact that the heater design may not be able to overcome. There's agitation in the tanks. There's instrument in the tank. These are all discussions to have with your customer. Hey, where's this laid out? Where does that go? And then, I mentioned orientation and size. The removal element of the tank is great. If a customer misunderstands that, they may actually bend an LTFX, which I'm still amazed that got out. And then there's insulation. We talked about insulation. It's an easy calculation. We can walk through that. I'll show you the calculators at the end, but we can walk through that if you want. We do that mostly in heat trace. But that is your that goes to your losses, right? That's your support to your losses. Insulation is always going to help. It means the heater's going to be small. It's conservation of energy. Area classifications, we obviously meet all area classifications that you need for electrical connections. Just make sure you're using the right one. I talk about a lot of that in the technical basics. I'm moving a little faster here because of the timing. But back to area. This was a great example in Mosaic Potash where these tanks were designed to maintain temperature. They were well-insulated tanks. Everything looked perfect on paper. They waited till the middle of February with the tanks freezing cold, probably -10 or more, and they filled the tanks, and they couldn't figure out why everything froze up. No one, including myself, had thought to ask them when they're actually going to fill the tanks or when they were going to start the process or this facility. And so all the designs were done based around heat loss. None of them were about heat up. So if the tank itself is already cold and you've got all these heat sinks, it did not work out so well. Big learning lesson for all of us, really. So, back to the questions. I got a spreadsheet to make it easier. It's all illustrated in the catalog page if you walk through that. Repetitive, right? You get to know it, it becomes second nature to everyone. Your credibility, your perception to the customer, yes, I can help. I can walk you through all your options. I can give you examples. I can show you why you want to choose this over that. And that's the purpose of this, to illustrate. The engineering data sheets are great to sit down. They're great for AE if you fill them out for them. It's a little old school, but still very much valid. The I section of the catalog I'm going to walk through next time. The tank brochure, I do want to point out, has a nomograph. And if for any of you on the call who knows what a nomograph is, congratulations, we're on the same page. For any of the younger folks that haven't seen one or never have, The nomograph is very much a part of the brochure. You basically draw lines based on your tank size, dimensions, and it will give you an estimate of kW. I just caution you, be very, very careful depending on how accurate you are with your lines or how far off you are. You could be 5 kW off, you could be 100 kW off. Please do the calculations. Use it for an estimating tool if you like, but do the calculations or use the calculators I'm about to talk about and provide to you. Again, here's your basic heating calculation, which we've gone through many, many times. ChromaCalc. You'll have the unabridged version provided for you at the end of this. If you haven't used it, if you don't have it on your desktop or on your phone, get it. It is great for estimating. It will tell you, you know, am I 10 kW or am I 100 kW? It will get you 90% there based on, again, geometry, a couple parameters, and you're done. But what I really like about it is it does illustrate your thickness of insulation to your tank to your estimated heat loss. I oftentimes, when I'm working with a customer, again, building that relationship, I will show them along the graph where we are. If you go here, you get this much temperature. If you go there, you get that much temperature. You need that much thermal input. It's just a great, easy graph to kind of show them where they are. And then if you want to take it a step further, this tank calculator, and I still haven't nailed down who put it together, but it's fantastic, and it's become kind of the norm. It's a 2-page calculator. First of all, you've seen the thermal input equation. So that is, in this case, for the product, for the tank itself, and then the heat loss. And then down here, based on time, I mentioned time is very, very important. It tells you what size heater you need, based on your losses, based on your conditions. This is great because on the second tab, it will show you the calculations. It will tell you the volume we're talking about. It will tell you the specific heat you used. It will tell you if you have losses. And that's very, very valuable to show to a customer, to sit down and have the discussion, to build the value and credibility with the customer. And that is provided as well. So you'll put that on your desktop and have that with you, because you can sit down and design 90% of what we do with your customer. So you've got right there the 3 equations, boom, taken care of. Next time around, I know I'm getting to the end of the hour. I'm going to go through the configurators to specifically to make it, really. We have walkthroughs already available to watch, but I'm going to kind of show a quick calculation, a quick design to help you with budgeting. You should be able to have the discussion of budgeting with your customers right away. What do you have, allocated for this project? How much are you looking, to spend? More of the sales side of that, you need to find out where you fall into, for one, competition, and 2, to service the customer with what they need to, so they have a better idea when they're putting their budgets together. And that's sales 101 right there. So I'll show you how to use the configurator to help with that, and the catalog price page. Also, what you're selecting based on corrosion, design, temperatures. You're going to need to know what materials and products to select, and we'll go through that a little bit more in detail. And also get a little bit of an update on the pick and ship. I also want to show maybe a sales strategy to use this to your advantage. The biggest advantage about the pick and ship is the stock of only a few part numbers. And more importantly, you can use that as you go through the criteria of the application and the design of what is needed for the customer. And you can say, look, if the lead time's an issue, the price an issue, we might be able to get by with some of these standard products that are sitting on the shelf. And that's where you apply this for your sales model to, again, as they illustrate with the cheeseburger, the 80% of what we do. So with that, I will open it up to questions.